Hey guys, it's me again, Captain Corey, here to teach you some sixth grade science. Last time we were together, we talked about thermal energy's effect on phase change. This week, we are talking about water's role in weathering. And not the weather like the weather outside, but we're talking about how water can change what our world looks like. If you need to access your science journal, I will show you how. And if you don't need this part, you can just fast forward to the next part. Okay, first, what you're going to do is you're going to go to the RPS website, so rvaschools.net. I'll make it full screen for you. Then once you're here, you're going to scroll down and you're going to go to RPS at home. Once you get to this page, then you will click on middle school. And since we're doing sixth grade science, we're going to go to sixth grade. Then you're going to scroll down because now we're in week 3 and you're going to click April 20th, right? I'm just going to click April 13th for demonstration purposes. Once you get into it, you will scroll down until you see science, and then you will be able to click right here for the workbook. Once you click on this link, it will come up this. All right, so then you'll have your workbook in front of you. What you are going to do is you are going to go to File, and then you're going to click and make a copy. Once you make this copy, it will save onto your Google Drive. If you do not have access to Google Drive, what you can do is you can come up to File, Download, and you can download it as a Microsoft Word. If you don't have Microsoft Word on your computer, you can download it as a PDF. Once you click on Microsoft Word, it will download into your computer and it will come up and it will look just like this. All right, so like I told you guys last week, what I do so it doesn't look crazy is I kind of just delete the atom and just press enter until I get things on the page it's supposed to be. So day 1, it says prompting questions. So this is let you know which day you're supposed to do. And we have prompting questions. That's something new that we're going to do this week. And then also this is the next day 1 activity. And then we'll have day 2, which will be our weathering notes. And then we'll have a lab, which will just go like this so they can all be on the same page. And this lab will be explained to you. Definitely, I most definitely will do that. And then there's another additional lab that is optional that you could do at home. So day 3, right here, is where we'll have a gizmo where you can do an online simulation, right? And then we'll have some physical or chemical weathering task cards where you can read the description given and then tell if it is physical or chemical. And they're all here. Just make sure each set of task cards has its own page. So if it starts looking like this, just press enter a couple of times and bam, there we go. So that is how you access the workbook. So this week is going to be different, and we're going to have prompting questions in your notice and wonder sheet. Today is Engage and Explore Water's Effect on Weathering. Let's watch this video on the Statue of Liberty to see why it's made out of copper, but it's green. I'm going to show you the prompting questions first, and then we'll watch the video. All right, so if you go to the workbook that I just showed you guys how to access, you will see down here where it says See, Think, and Wonder. So for the past 2 weeks, we have had the See, Think, and Wonder pages as we have watched different scientific phenomena happen. Today, what I want you to do before we watch the first video is I want you to think about these questions. So it says pennies are made out of copper and are brown, and the Statue of Liberty is made out of copper and is green. How can they both be made out of copper but be different colors? Then I want you to think about what element does copper react with in this video, all right? So remember, write down at least 3 things that you see, 3 things that you think, and 3 things that you wonder. Let's watch this first video.
The Statue of Liberty, the symbol of freedom and liberty and America and everything that's great about this country. There she is, Lady Liberty, standing there in all of her blue-green glory. But she wasn't supposed to be this color. The Statue of Liberty was a gift from France back in 1885 as a way of commemorating our fight for independence and their own aspirations towards democracy. This 305-foot statue was built over 9 years in sections of copper skin on top of an iron skeleton. According to the National Park Service, the statue has about 30 tons of copper, which is enough to make 435 million pennies. Yes, bright reddish gold pennies. But the Statue of Liberty isn't the same color as, well, any penny I've ever seen. So, how to explain Lady Liberty's color change? Simple. You change colors too if you stayed outside in that New York City polluted air for almost 150 years. I'm kidding. Well, mostly. It all comes down to chemistry. During her first few decades in the Big Apple, the statue slowly turned from that shiny copper color to a dull brown, and then finally to the blue-green, or as they say back in France, verdigris that we see today. Officials suggested trying to restore her to the original color or painting her, but after public outcry, they decided to leave her the way she is, and she'll continue to look like that until Dr. Zayas shows up. Anyway, her color change happened because of oxidation reactions between copper and the air. Now, I know some of you smarty pants might be saying, well, duh, but copper's patina is more complicated than just one reaction. It's due to about 30 years worth of oxidation reactions creating a mixture of minerals. So let's get into it. Now, when an atom loses electrons in a chemical reaction, it's called oxidation. This process was first observed in reactions that involved oxygen, hence the name, but it can happen with other elements too. The color change from coppery red to blue-green was bound to happen as soon as they parked her in New York Harbor. And here's why. First, there's all the oxygen in our atmosphere just hungry for electrons. Then you add all the elements in New York's polluted air into the mix and voila. In the first reaction, copper gives up electrons to oxygen. That creates this mineral, cuprite, which you can see is a pinkish red. Next, cuprite loses more electrons to more oxygen, forming blackish tenorite. The black color of this tenorite explains why the statue slowly got darker over the years. Now, let's pivot to sulfur reactions. Sulfur finds its way into the atmosphere through natural processes, including volcanic eruptions. But humans have also put a lot of it there too, with their boats and cars and pesky airplanes and factories. So when sulfur dioxide gets together with water, it forms sulfuric acid, which can form green stuff with copper oxides. Now, back.
All right, so basically, that's why the Statue of Liberty is green. All right, so now we're going to watch the weathering brain pop to just give us some more background information about weathering. If at any time you need to pause or rewind, feel free to.
Ow. Dear Tim and Moby, what is weathering? From Melissa. Yep, I bet weathering is responsible for those cracks. Weathering is the process that breaks rocks down into fragments and eventually sediments. Soil formation depends on sediments from weathering, and those same bits make up sedimentary rocks. Weathering can even change the Earth's surface over time. Mechanical weathering breaks down rocks without changing their chemical composition. Forces like growing plants, expanding ice, lightning, and mineral crystal growth can all cause mechanical weathering. Plant roots grow into cracks of rock where they can find water and nutrients. When these tree roots get big enough, they'll force the concrete apart. Ice can do the same thing. In cold weather, water freezes and forces rock apart, creating all sorts of pressure. Then it gets warm, and that ice melts, leaving cracks and making the rock weaker. Chemical weathering happens when water, air, or other substances react with the minerals in rocks, soil, and building materials to change their chemical composition. When water reacts with carbon dioxide in the air, it makes carbonic acid. Carbonic acid reacts with the calcite in limestone. Over thousands of years, an entire cave like this can form from chemical weathering. Ah! I'm ready to go. What about you? I think you better find another place to skateboard.
All right, so that was our brain pop weathering video. So today's explore activity is going to make us go outside today. So I'm going to share with you what it looks like in the notebook, and then I'm going to explain to you what we're going to be doing. So it says day 1, weathering. Did you know that some of the world's best known structures have fallen victim to weathering? Weathering has worn down the stones on the statues of Esther Island and on the pyramids in Egypt. Structures such as the Eiffel Tower and the Taj Mahal and the Statue of Liberty, which we just saw in the video, have been weathered down by acid rain and other chemicals in the air. And we saw in that video with the Statue of Liberty that there's more chemicals in the air than like just oxygen and just carbon dioxide. All right, so for this activity, you will find an example of physical weathering in your neighborhood, and then you will find an example of chemical weathering. Use the chart to record the data or for the examples that you find. So I want you to go out with parent permission, with a buddy, and go out and look for different signs of physical and chemical weathering. And you can do this like if you see like a structure, buildings that have been there for a long time. You don't have to look just at rocks. You can also look at buildings, statues. Richmond has a ton of statues. All right. And then I want you guys to answer these questions down here where it says, how did you identify your first example as physical weathering? And then how did you identify your second example as chemical weathering? All right, so that is the project that we have for today. Also, I want you guys to, if you have any really good things for your Notice and Wonder page that you want to shout out for next week, I want you guys to just go in to the Nearpod and put in the code and then type in the things that you see, the things that you thought, and the things that you wonder. Make sure you put your name and your school, and then look out for the next week for a shout out. All right, until next time, it's been Science with Captain Corey.